You. I hope all of you are doing well. So in today's class, we are going to discuss about software maintenance. Now, software maintenance basically refers to any modification that is brought about with the software application after the software application has been delivered to the customer. So any post-delivery alteration that is brought about in the software system um, is called as maintenance. Now, maintenance can be called for various purpose, or maintenance can be performed for various purpose. So, one of the reasons for which maintenance may be performed is for correction. It may be for adaptation, it may be for perfection, or it may be for prevention. So we'll learn about each type of maintenance in the upcoming class. But for now, just remember that any post-delivery alteration that is brought about in the software application is called as maintenance, and it can be for either perfection, correction, adaptation, or prevention. Now, software maintenance is a very important activity for many organizations because in order to increase the lifetime of the software, or in order to increase the use time of the software, what we need to do is we need to constantly bring about a change in the software application. So if we do not bring about a change in the software application, then software application may not be put to use. So in order to meet up to the changing requirement of the customer, what we need to do is we need to constantly bring about a change in the software system. So it's a very crucial activity in case of any software organization. Now, maintenance is inevitable for almost any kind of product. Just see, this is what we discussed about. So it may so happen that during the use time of the software application, the customer may come up with several demands that may be for correction, demand that may be for prevention, demand that may be for perfection, and demand that may be for adaptation. So there might be different types of demands that may come up from the customer regarding the software. So in order to incorporate those demands into the software application, what we need to do is we need to perform software maintenance. So most product needs maintenance because of the wear and tear caused by use. So this is one of the reasons why we need to have maintenance. But this is not only the reason that I've already specified. It can be for adaptation, perfection, correction, or prevention. It's the common conception that only the bad software system product or software product needs maintenance, but this is not true. Actually, what happens is that in order to enhance the use time of the software application, what we do is we keep on bringing about new changes or keep on incorporating changes into the existing system. So the opposite is true. So bad software is often or bad products are often thrown away. Good products are maintained and used for lifetime. Now, software products needs maintenance for four different reasons. So this we have already highlighted. We said that it may be corrective, adaptive, perfective, or preventive. Now, corrective maintenance. So, corrective maintenance carried out in the software system in order to correct bugs that has been observed whenever the software system is being put to use. So, if there might be a situation where some errors have migrated from the development phase to the use phase. So, if the errors were not detected during the development phase, so what we need to do is and if the error is detected, and if the same error is detected during the use phase, then what we need to do is we need to initiate corrective measures for overcoming the effects of that particular error. So that is the reason why what we need is we need corrective maintenance. So corrective maintenance and maintenance that is carried out in order to correct problems or errors that are observed during the use of the software application and to enhance the performance of the software product, because if the bugs and the errors are not corrected, then it may so happen that the software system may not be put to use. Now, adaptive maintenance, and maintenance that is carried out in the software system in order to port the software application to some other environment. So, for an example, your software system was working in a Windows operating system. Now you want the same operating system to work in Linux operating system. So now what we need to do is we need to bring about adaptive change to the software system so that they can adapt to new operating system and perform the desired activity. So that is what adaptive maintenance is all about. So adaptive maintenance is maintenance that is brought about in the software application to put the software application to the new environment. Now, perfective maintenance is a maintenance that is carried out in order to enhance the capabilities, existing capabilities of the functions, or to enhance the capability of the software application itself. So, perfective maintenance is carried out in order to support new features required by the user to change some functionality of system due to customers' demand. So, this is what is called as perfective maintenance. If an example, if the customer now wants results with greater degree of precision, so now what we require is we require perfective maintenance, right? If a customer wants new set of features, so again, again perfective maintenance may be carried out, right? Now preventive maintenance basically refers to maintenance strategy that is initiated in order to overcome a problem that has been forecasted, or a problem that may affect the working of the software system in future. So what we need to do is we need to forecast possible set of problems that may be encountered in the software system, that may be encountered by the software system, and what we need to do is we need to take necessary measures for that. So that is called as preventive maintenance. So to overcome any foreseen event of crisis. So now let us try to see what is the distribution of total amount of effort for different types of maintenance. So you see that almost 47% of maintenance, 47% of the maintenance effort is dedicated for perfective maintenance. Almost 21% of the development of maintenance effort is meant for corrective maintenance. Almost 27% of the maintenance effort is meant for adaptive maintenance, and almost 5%, 4 to 5% of the maintenance effort is meant for preventive maintenance. So you see that the major share of maintenance effort is dedicated for perfective maintenance, because whenever we develop a software system, what we ensure is we ensure that the software system is to the desired extent it's correct, and it's capable of delivering the expected results as specified in the SRS document. So any advancement that is to be made to the software application post the acceptance of the software system by the client can be perfective in nature. So that's the reason why almost 47% of the maintenance effort is dedicated for perfective maintenance. Almost 21% of the total maintenance effort is dedicated for corrective maintenance. Almost 27% of the maintenance effort is dedicated for adaptive maintenance, and almost 5% of the maintenance effort is spent for preventive maintenance. But now just see this, these are just approximate assumptions, that these are the proportion of the effort dedicated for different types of maintenance. Now, why do we need maintenance, or what are the causes for maintenance? So, as we have already highlighted, maintenance can be for correction, perfection, adaptation, or prevention. So, during development, software is not definitely anticipated to last for very long. So whenever you're developing a software application, it may so happen that a software application may not be expected to last for very long. But if the customer wants to prolong the life of the software system, or the customer wants to continue the use of the software system, then what we need to do is we need to continuously maintain the software system, or bring about a change in the maintenance system. So the rate of hardware obsolescence. So this is also it's one of the factor that is influencing the working of the software system. So it may so happen that due to the continuous advancement in the hardware domain, what we may have software systems that may not qualify for the latest advancement in the hardware domain. So what we need to do is we need to constantly bring about a change in the software system that is capable of making use of the hardware system, right? Now, user wants existing software to run on new platforms. They want the software to run a new environment, and a new hardware system, right? Again, a new software system and with enhanced features. So you see, these are the major reasons or major causes for maintenance. So software system normally is not expected to run for a long period of time, but if the customer wants to increase the usable time of the software system, then what we need to do is we need to bring about change in the software system. Now rate of hardware obsolescence. So it may so happen that it has so happened that with time there's continuous advancement in the technological domain, because of which there's continuous advancement in the type of hardware system that is being built. So it is very necessary for us to bring about change in the software system to adapt to the new environment or new hardware system. So user may want the existing system to work on new platform, new environment with new set of softwares with enhanced set of features. So these are the reasons why what we need maintenance. So you can go through this as well. So there are basically laws postulated by different authors related to maintenance. So we'll be trying to go through the laws that are postulated by Manny Meyer Lehman and Laszlo B. Lady. So these are called as three laws of maintenance. So these were proposed by Manny Meyer Lehman and Laszlo B. Lady. Again, I'll repeat it. So these are called as Lehman's law of maintenance, proposed by Manny Meyer Lehman and Laszlo B. Lady. So you can just go through the law. So the first law states that a software product must continuously change or become progressively less useful. Now this is very true. Now a software product has to continuously change in order to meet up to the changing requirement of the customer. And if it does not incorporate in it the changes, then definitely the software will be less useful, and eventually the software will be forced for retirement. So our software product has to continuously change maybe for correction, perfection, adaptation, or prevention, but it has to continuously change. So there has to be constant development that is brought about in the software application to meet up to the changing expectation of the customer. So if changes cannot be incorporated into the software system, then software system will definitely become less useful. So this is the implication of the first law. So software product must continuously change or become progressively less useful. Now the second law states that when a software is maintained, its structure tends to degrade. So unless active efforts are made to avoid this phenomena. Now to see what happens is that whenever more and more changes brought about into the software application, the structure of the software system definitely tends to degrade or become the stability of the software system will degrade. So now what we need to do is we need to ensure that whatever changes we are bringing about in the software application, these changes will have a very less implication in the basic structure of the software system, and thus does not hamper the working of the other functions that are there in the software application. So it is very much essential that whenever changes are being introduced in the software application, the changes are made seamless, and a smooth transition is made, because the change that's being introduced in terms of functionality or enhancement to the functionality may work adversely or may affect the working of the other functionality. So it is very much important. So that is the implication of the second law of maintenance, right? So when software is maintained, its structure tends to degrade unless active efforts are made in order to avoid this. So in some of the literatures you may find the law stated in a different manner. So it may be stated as more and more changes are brought about, the structure of the program tends to degrade. So it is stated in that manner as well. Now the third law of software maintenance proposed by Lehman was over a program's lifetime, the rate of development is approximately constant. Now to see here, what we have is we have during development time also what we are doing is we are trying to evolve a system, and during maintenance also what we are trying to do is we are trying to evolve a system. So it is just the naming of the phases that are different, but in both the phases, whereas in case of development phase as well as in case of maintenance phase, what we tend to do is we tend to evolve the system. So it is said that over a program's lifetime the rate of development is approximately constant. So you see that subsequent amount of effort is dedicated for maintaining software application, because during maintenance also what we are trying to do is we are trying to evolve a software system. Now let us try to understand what is reverse engineering, right? Now in situations, now there might be different types of software systems that you may be asked to maintain, right? Okay, in situations it may so happen that In a situation, it may so happen that you may be asked to maintain a software application with which the set of relevant artifacts are available. So, for example, what I imply by that is you have the SRS document available, you have the specification document available, you have the design document available, you have the code available, right? So, then what we need to do is we need to just learn about the change requirement. That means what are the changes that are to be introduced in the software application, and once you have an idea about the change requirement, then what we can do is we can bring about the change in the software application and incorporate those changes into software application so that it meets up to the expectation of the customer. Now, this can be one of the situations of the software system that you're asked to maintain, where all the necessary artifacts that are required for maintaining the system is available readily. But in another situation, it may so happen that you may be asked to maintain a legacy system. Now, legacy systems are systems with which the necessary artifacts may not be available or may not be in usable format, right? So in that case, what you need to do is you need to regenerate everything. So you need to regenerate the specification document, you need to regenerate the design, and then you need to understand the design, and then you need to go on for maintenance work. So in that case, what we have in the latter case, what we have is we have effort dedicated not only for maintenance but effort dedicated for reverse engineering as well. So that is the process of reverse engineering. So reverse engineering is the process of recovering all necessary artifacts that are there pertaining to the system from the program code. Right. So reverse engineering, just see it stated here. So it is the mechanism for extracting all necessary artifacts from the program code. So reverse engineering is important maintenance technique where several existing software products are unstructured, lack of proper documentation, where develop software engineering principles have not been actually deployed for developing software applications. So just see, this is the importance of reverse engineering. So it's very much important to understand reverse engineering, because in most of the system what would we require is we require reverse engineering mechanism to be adapted. So in today's class, what we have learned about is we have learned about what is software maintenance. We have learned about why do we need maintenance. We have learned about what are different reasons why we need maintenance. We have learned about each of the types of maintenance. We have learned about corrective, adaptive, perfective, and preventive maintenance. Then we have learned about the distribution of the maintenance effort among different types of maintenance, and then we have identified some of the notable causes for maintenance. And then we have been through the three laws of maintenance, where we have discussed the laws that are proposed by Manny Meyer Lehman and Laszlo B. Lady. So there are three laws. Again, I will repeat the laws. So the first law states that software product must continuously change or become progressively less useful. Lehman's second law states that when a software is maintained, its structure tends to degrade. So unless active efforts are made to avoid the phenomena. Then Lehman's third law states that over a program's lifetime, the rate of development is approximately constant. Now we have learned about software reverse engineering, right? Where we have learned about why do we need reverse engineering, in which situation we need reverse engineering, and we've learned about the implication of maintaining a legacy system as well. So in the next class, what we're going to learn about is we are going to learn about how we are going to carry out reverse engineering, and we are going to learn about different maintenance models. Thank you very much.